Hello, in this video I may be talking a little bit about how we can score our models on our training data. And scoring them is going to involve learning some new metrics and terminology. It turns out there's different kinds of errors, and if sometimes we'll care more about one kind of error than another, we might want to use different metrics to deal with that case. So for this, I have some really simple dummy data. Basically, I have this data frame that has an X column, and the X column is a number, and then the Y column is a Boolean, and it's true whenever X is positive and false when it's negative. Okay, so not much data there, and just for simplicity, I'm kind of breaking it into the first half and the second half. I wouldn't normally do this, right? Because maybe the data is not shuffled, and maybe I'm kind of getting very different data in the two halves. So this is just trying for an example. So there I have it. I have my training data and my test data down here. And if I want to try to figure out what is the relationship between Y and X, and then measure the model's understanding of that relationship, I'm going to use some sort of scoring function, right? So I'm going to do this with a logistic regression. Remember, this is not really a regression, it's actually a classifier, right? Because I have this categorical data that I'm trying to predict. And so I'm going to train one of those, and then I want to score it. So first step, right, is I'm going to say LR equals logistic regression. Great. And then I'm going to say LR.fit. And when I'm fitting, let me actually just try to run this. Once I run it, I can actually hit Shift Tab and get a hint. I have to give it the X data and the Y data. And so I'm going to give it both those things from the training data first. And so I'm going to say training data, and then the columns I want are just X. And then the thing I'm trying to predict is just the Y value, just like that. And then after I do that, I can basically run a command that's very similar, and that command is score. I can evaluate how well it does on the test data. And I get 0.75. So what is this score function doing? It turns out it's a shortcut, and I'm just going to show you a little bit in the documentation what it's doing. If I head over here, I see that the score function for the logistic regression is giving me the mean accuracy. And if you look at other estimators, they might be doing other kinds of, using other metrics for the scoring. Okay, so mean accuracy. So that's the default here, but it turns out there's lots of different metrics we could use. And so if I go to the metrics page for scikit-learn, I can see that, hey, there's a whole bunch of metrics here related to classification, clustering, which we haven't talked about yet, and then a whole bunch related to regression as well. And so the one I'm using right now, the default, is that accuracy score, right? You saw that, how it's saying here that we're just getting the accuracy, and accuracy is very simple. It's, well, what percentage of the times did we get it right? And so I certainly could have, instead of using that score function, I could have used this one myself. And I think that's a good thing to do right now, because once you understand how to use this manually without the shortcut, then we'll understand how to use these other functions as well. Okay, so I can see this is in the metrics submodule. And so when I head back here, I'm going to do this. I'm going to say, and this was that page I was just on, I am going to say from sklearn.metrics import accuracy score. Okay, and let me just run that. And when I call accuracy score, I hit Shift Tab here. Basically what I'm doing is I'm saying, well, what are the true values, and what did my model predict? Okay, and so there's different ways I could do that. I mean, I could say, well, the true values are A and B, but I actually predicted A and C, and it turns out if I do that, well, I'm just 50% right. So this was my actual values and my predicted values. So let me actually try to get these from up above, right? So before I was calling this score thing, and then I was trying to give me my X values and my Y values, and so I'm going to pull pieces from this. The first piece I'm going to do is I'm going to actually figure out what the predicted values are. So those are going to be the predicted values, and I actually have to call predict here instead of score, right? When I'm predicting, I'm not giving it any y values, right? Predict tells me what the y values are. And then I also have to have my actual, right? And my actual was just the second piece from before on that column. So maybe actually let me just do this. I'm going to say, let me look at the actual values and the predicted values as a list. Okay, and I can see the actual were true, true, false, false. But I'm actually getting true, false, false, false. And so the second one is the error, right? So I'm going to be wrong 25% of the time. And so accuracy is actually going to be 75%, which is what we saw before. And we're going to see it here too when we actually pass in these two things. I pass in the actual values and those predicted values. Right, so I'm going to get that 75%. Okay, now, so that works fine, but there's going to be cases where we don't want to just know how often we're right, but we want to know about, about what kind of mistakes we're making, right? So, for example, let's imagine different things that this y column might be. Let's say that this y column means it's a good investment. Maybe it's for a stock or something. I don't need to know about every good investment, but if I have some system that kind of tells me like, hey, these are some good investments and it's always right, and it doesn't tell me about every good investment, that's a pretty good system. In contrast, maybe this is telling me, I don't know, is somebody contagious for COVID-19 or whatever, right? And in that case, it's much safer to make the mistake of saying they are contagious even though they're not. So there's different kinds of errors, false positives and false negatives. And so there's a lot of metrics based on that. And the simplest place to start is with something called a confusion matrix. And a confusion matrix shows the categories that things actually are and then how they mistakenly get classified as other things. And so just like before, just like we have an actual and a predicted list, when we have a confusion matrix, we're going to do the same thing. So imagine I had pictures of animals and I had 4 dogs, 3 cats, and 2 mice. And but then I have some machine learning system that's looking at those pictures and is maybe predicting these other things. What I could do is I could create a confusion matrix using scikit-learn, right? This is also under metrics, just like accuracy score. And so I can create one of these. And just like with the accuracy score, I can put the true values and then the predicted values, just like that. So I'm going to say actual and predicted. And this is a little bit confusing because each one of these values is kind of showing us how many categories fall into like a specific actual category and a predicted category. And it's not really clear to line it up, right? Well, is this first row dog or is it cat? And so what people will often do, right, is that they'll say labels like this. And just to control the order. So for example, maybe I want to say like cat, dog, mouse, just like that. And then if I pass in these labels, it's going to be a little bit different, right? Whereas if I say dog, cat, you can see these numbers switched a little. And another reason for this, besides just controlling the order, right, so that makes sense, is that I could, maybe there's things that I know exist but didn't even show up in the data, right? There's no horses, right? So let me actually really kind of talk about what these numbers mean. I think it'll be a little easier to put in a data frame. And so I'm going to put this in a confusion matrix here. And now let me put this in a data frame, pd.dataframe, confusion matrix. And when I'm creating a data frame from this, both the index and column labels are going to be the same, right? So I'm going to have it just be like this. And so when I'm looking at this confusion matrix, what does it mean? So the row means what it actually is, and the column is going to be what it got classified as. Right, so I can see in this, right, that there's 4 dogs, and of those 4 dogs, it correctly classified 3 of them as dogs, but one of the dogs was mistakenly identified as a cat. Okay, it looks like there are 3 cats in the system. 2 of them were correctly identified as cats, and 1 was considered a dog. And then I can see other things here, like, well, the system's really good at mice, right? It always correctly calls the mice and doesn't mix them up with anything. And so this is useful, right? When I have a list try matrix, I can see what ways the classifier is confused. Hence, it's called a confusion matrix, right? It's showing me how the model is confused, right? So hopefully that's helpful. Now, it's very common that we'll be having these confusion matrices where the classes, instead of being, different animals, it might just be true and false. That would be for a binary classifier where I just have these true and false values. And so let me actually go back to what I had before, right, when I was computing this accuracy score. And let me create a confusion matrix here. And maybe I'm just going to copy some of this down here. I'm just going to grab this. And in this case, the labels are false and true. And it doesn't do anything. Okay, so I have these different categories. And just like before, I think it's going to be helpful to put this in a data frame, right? I'm going to put a data frame here just like that. And so here, again, the row is telling me what it actually is. And then the column is telling me how those got classified. And ideally, in a perfect world, right, everything will be on the diagonal, right? That means there were no mistakes made. There was no confusion. Okay, so I have that. And it turns out there's special names for each of these four values. And so I'm just going to go through this quickly. The top left one, actually, let's start with the bottom right. So if I go to, let me put this in a actual data frame. So that's going to be my confusion matrix is a data frame now. Okay, and if I go iloc 1, 1, that's going to be that bottom right. That's going to be called true positives, and you're going to practice kind of remembering these words. They're important terminology, right? So I'm going to do this, and then if I had been smart with this example, I would have made sure all these numbers were different so we could more easily identify, right? And then the other numbers on the top left, and those are true negatives, right? So true means that the model is doing the correct thing, right? So in this case, I have one. You know what I should really do is I should do it like this: true positives, true negatives, right? People often abbreviate it this way. And then there's the mistakes, right? The mistakes are false, right? So I'm going to say false and false. And so what are these called? The false positives. Well, where are those? So false positive means that in this column, right? And so it should be false, right? That's what it actually is in the data. But it gets classified as true, right? So what does that mean? That means I'm in row 0, column 1, and then the opposite down here, right? Sometimes it actually is true, but the model says it's false. That's a false negative, and false negative, just like that. Right, so these are the four different cases I'd have. And a lot of the statistics we're going to be looking at in the next video are combinations of these, and I'll be kind of talking more about why those are meaningful.